Hi grade 12s, thank you for joining me once again. Today we are going to be looking at analytical geometry in maths, and remember, analytical geometry in your final exam is big marks. It's about 27 to 29% of your final exam paper 2. So it's a section where if you study hard, you can get really good marks. Of course, not just study hard, but study smart as well. So one thing is, yes, you can go over past papers, but the main thing is you need to make sure you understand the concept, and you need to understand how analytical geometry relates to Euclidean geometry, because the two certainly do have things in common, and you sometimes have to rely on some of the geometry theorems to help you with analytical geometry. Remember, when we talk about analytical geometry or coordinate geometry, we're talking about geometry on a Cartesian plane. So that's where we use the x and the y axis. In grade 12, in your final exam, of course, you expected to know all of the analytical geometry you've learned so far. So going back all the way to grade 9, grade 10, where you've learned the distance formula, midpoint formula, how to find the equation of a line, how to find the gradient of the line, and also how parallel and perpendicular lines' gradients interact. So you expected to remember all of this information, and of course some formulae will be given to you, but unless you've actually practiced, you will not know where to use the formula and when. So if you're really stuck, yes, you can look at the formula sheet and find the formula for equation of a straight line, but you need to be able to understand when to use that formula. And in order to understand that, you have to do lots and lots of practice of similar types of questions. All right. So one of the big things you learn in grade 12, and the big concept, is the equation of a circle that's not centered at the origin. So if we have a look, we know that generally the circles that we are familiar with were centered at 0, 0, and I'm just going to make a rough sketch here, so it's definitely not accurate. But there we go. So that's a circle centered at 0, 0, the origin being the center of the circle. And of course, remember, with a circle, all the points on the circumference are equidistant from the center. Okay, and of course the diameter is the longest distance of the circle. All right, so the radii are not supposed to be squiggly lines, they're actually straight lines, but those radii are obviously all the same value around your circle, taking you from the center to the circumference. So in grade 12, what we do is we take the circle and we move it off center. So no longer is the center going to be at 0, 0. Certainly it can be, but most of your questions will be based on a circle that's got its center based somewhere else. So it still has all the properties of a circle, it's just the center that has moved. So if you've got P, which is the point xy, is a point on a circle, so let's look at our circle that I've drawn there. P is the point xy. And O is the center AB, so let's just say the center's there, AB. Then the equation of the circle is given by x minus a squared plus y minus b squared is equal to r squared. So a and b being the coordinates of the center of the circle, r squared being the length of your radius squared. Now, you can certainly derive this and show how we get to this equation. You don't need to know how to do it for exam purposes, but it's really very simple, because if we just use the distance formula and find the distance between O and point P, using the distance formula, you will get out that the length of the radius squared would be x minus a squared plus y minus b squared is equal to r squared. It's just a simple application of the distance formula. And in fact, a circle centered at 0, 0 is just now the ordinary case where the center is 0, 0, where a and b is 0, you'll get x squared, x minus 0 is just x, plus y minus 0 is just y, is equal to r squared. So that's the traditional circle equation, which we should all be familiar with by now. So if you look at a center that's no longer centered at 0, 0 with the center AB, we simply then have the coordinates of A and B substituted into the distance formula to give us the length of the radius squared. Okay, so that is something that you will be expected to know. You need to be able to apply this formula to find the equation of a circle. Now, your questions can definitely change, and the way they ask the questions can change, but when you are talking about finding the equation of a circle off center, this is the formula that you will always use. To find the equation of that circle, you need the coordinates of the center and you need the length of the radius. Now, sometimes you would be expected to work out the coordinates of the center and you'd be expected to work out the length of the radius. So this is a typical example that you could be expected to answer. It's certainly for your test and your exam. So this is a typical type of question you need to know how to do. So in this question, we are asked to determine the center and the length of the radius of the following circle. So we can see that in this form, as the equation is given to us, we cannot make out the center of the circle and we cannot make out what the length of the radius is. So we need to do a little bit of work. So the first thing you want to do, guys, is you want to make sure that your x's are grouped together, your y's are grouped together, and your constant is on the left-hand side. So we'll put 2x squared plus 4x together, plus 2y squared minus 2y, and take the 10 over to the right-hand side. The next thing you need to make sure is that the coefficient of your x squared and y squared term is 1. So to do that, we can see that we can divide through by a common factor of 2. So we end up with x squared plus 2x plus y squared minus y is equal to 5. Now that the equation is in this form, we can complete the square with the x squared plus 2x and complete the square with y squared minus y in order to find the center of the circle. Now remember, when you complete the square, you're going to add values into this equation that were not there before. So whatever you do to this side, to the left-hand side of the equation, you've got to do to the right-hand side of the equation. So to complete the square, I bring down the terms x squared plus 2x, plus we then add a half of the b term, so it's a half of 2, which is 1 squared, plus what we need to do, and in fact do it straight away so you do not forget to put it in, 5 plus 1 squared on the right-hand side. So I've added a 1 squared on the right and I've got a 1 squared on the left. And then on the left-hand side, we still need to complete the square of y squared minus y. So it's y squared minus y plus a half of minus 1, which is minus a half squared. And we add that onto both sides as well. All right, so we're going to just carry through onto the next slide. So it's plus minus a half squared. So I've got x squared plus 2x plus 1 squared plus y squared minus y plus minus a half squared. And on the right-hand side, I have 5 plus 1 plus a quarter. So to complete the square with the x terms, we end up with, so we're basically factorizing the terms in x. Square root of x squared is x. I bring down the sign of the middle term, so it's plus, and the square root of 1 squared is just 1. So I end up with x plus 1 squared plus y minus the square root of a quarter is just a half. So y minus a half squared is equal to 6 1/4. All right. Now, guys, this is in a form that's more similar to x minus a squared plus y minus b squared is equal to r squared. So do you see we had to manipulate the original equation and take it from there to a point where we can get it in a form that we now recognize. All right, so we can recognize straight away that a and b are the coordinates of the center of the circle. So therefore, the center coordinates, remember to change your sign. So we've got x plus 1 squared. So therefore, x is equal to minus 1 is the x value at the center. And y is equal to a half is the y value at the center of the circle. The radius squared is equal to 6¼ So 6¼ is the same as 25/4. This is very important. This is the radius squared, but they did not ask you for the radius squared. They said find the length of the radius. So to find the length of the radius, you have to take the square root of 25/4. So the square root of 25/4 will be giving me 5/2 or 2½. And remember, when you take the square root, the answer is always plus or minus the square root. But we know that a length is a positive value. We cannot have a negative distance. So therefore, the length of the radius cannot be negative 5/2. It must be positive 5/2. So therefore, in this question, we've got the center of the circle is -1½. Those are the coordinates of the center. And the length of the radius is 2½ units, or 5/2 units. All right, guys, hopefully you can see how important it is to complete the square and to understand all of those steps that you learned in grade 11, those steps of completing the square. They're so important in analytical geometry. And once again, we go back to the fact that in maths, everything is linked. You cannot learn things in isolation, because you're going to draw on all of the knowledge you've had before to answer questions, even in analytical geometry. Algebra is so important. All right, guys, we're going to take a quick break. When we come back, we're going to look at tangents to circles. Welcome back, everyone. Today we are talking about circles, and we are looking at analytical geometry and finding the equations of the circles using analytical geometry. Certainly you will have to remember some of your circle geometry theorems as well when we are answering questions in grade 12 analytical geometry, especially because we talk about tangents to circles. And there is a theorem or two that you need to remember from Euclidean geometry to be able to answer some of the analytical geometry questions. Now remember, because we're talking about geometry, the two sections, Euclidean geometry, analytical geometry, they go together. Don't think of them as two completely different sections. When we're talking about circles, certainly those theorems that you learned in grade 11 geometry, all those circle theorems, those become very important in analytical geometry when we look at circles of center and when we look at tangents to circles. So we're talking about a tangent. What is a tangent? So a tangent is basically a straight line that touches the circumference of a circle at only one point. So if we have a rough sketch of a circle, the tangent will be the line drawn to the circle where it touches the circle at just one point on the circumference. Now this is where I was saying it's important to remember your Euclidean geometry theorems, because the one thing you need to remember is that the radius of a circle is perpendicular to the tangent at the point of contact. So say we know that that's the center of the circle, then the radius, which is the line drawn from the center to the circumference, will be perpendicular, form 90 degrees with the tangent at the point of contact. Guys, this theorem is super, super important. It is an axiom. Axiom meaning you don't need to be able to prove it. You just need to accept that it's a result, and you need to use it every time it becomes applicable in your question. Why is it so important in analytical geometry? Because when you get perpendicular straight lines, you should remember that the product of the gradients of perpendicular lines is equal to -1, and that's why this theorem is so important. So if you have a look at this diagram that we've got drawn, that's a lot neater than the one I've just put up before this. If you've got a tangent AB touching the circle at point D, which is with coordinates x, y, and you know that the center of the circle has coordinates AB with radius r, then CD will be perpendicular. You can see that little 90-degree sign there, that tells us that CD is perpendicular to AB. This is incredibly important because when we have perpendicular lines, we can say that the gradient of AB times by the gradient of CD is equal to -1. Okay, so often you'll be asked to find the gradient of AB or the equation of AB, and you'll be given the center point C and you'll be given the point of contact D. So you will be able to then use the coordinates of C and D to work out the gradient of line CD, then the gradient of AB, and then use the coordinates of D to find the equation of the tangent AB. We will look at an example that explains that in a little bit more detail. But say, for example, I know that the gradient of CD is 2. All right. Then if you look at what we say here, the gradient of AB times the gradient of CD is equal to -1 because they are perpendicular lines and the product of the gradients is equal to -1. So if I know that the gradient of CD is equal to 2, to find the gradient of AB, all I do is I take the negative reciprocal of the gradient of CD. So reciprocal means turn that fraction around so that the numerator becomes the denominator and so that the denominator becomes the numerator. So 2 can always be written as 2 over 1. So therefore, the gradient of the line AB will be 1 over 2. You see, we flip that number around. We take the reciprocal and you change the sign. So we can see if the gradient of CD is positive 2, then the gradient of AD is negative 1/2. Why would that be the case? Well, if I take 2 and I multiply that by negative 1/2, my answer will be negative 1. So I can see that the product of the gradients of perpendicular lines is equal to -1. And it works both ways. If you are given the gradient of AB, you can always find the gradient of CD. Okay, so remember that. Remember also when you're working with gradients of lines, we need to be careful with which coordinates we substitute as x1, y1, and x2, y2. And we're going to have a look at doing that substitution very nicely and carefully for the next question. Okay, so this is an example, a typical type of example that you could be given, a typical type of question that you could be given in the exam. You say, given the point P, which coordinates 2 and -6, on the circle x minus 4 squared plus y plus 5 squared equals 5, find the equation of the tangent at P. So the first thing I like to do is when I read a question like this is to make a sketch. And on the sketch, I mark down all of the information that's been given. So we've got a circle. We see that the center coordinates are going to be 4 and -5. Remember, you always swap the signs when you take them out of those brackets. So the center of the circle will have coordinates 4 and -5. And then you've got a tangent, so you're given the point P with coordinates 2 and -6, so let's just say that that's somewhere there. And then there's a tangent drawn at that point P. Of course, that should be a straight line, not a squiggly line, but I don't have a ruler, so we will accept that that represents a tangent. So at the point P, there's a tangent. Okay, so I've literally taken all of that information that they've given me, put it into a sketch, and that should hopefully make it easier because now I can see what it is I'm dealing with. Also, just to mention here, the radius squared is 5. So even though we don't need it in this question, just remember that that's the radius squared. That is not the length of the radius. The radius would be the square root of 5. Okay, so just keep that in mind because sometimes we do get questions based on the radius, but not in this one. Find the equation of the tangent at P. So firstly, we realize that a tangent is a straight line. So therefore, the defining equation is y is equal to mx plus c. So that means to find the equation of the tangent, I need the gradient and I need the y-intercept. To do that, using the information I've got, I need to find the gradient of the radius. Okay, once I've got the gradient of the radius, I can then find the gradient of the tangent using the fact that the radius is perpendicular to the tangent. Let's just call the center the point O. You don't need to, but we're going to call it O because it's going to make it easier when we're referring to these points. So we'll let the coordinates at the center be represented by the point O. So how are we going to go about this? We are going to find the gradient of OP, then the negative reciprocal will give me the gradient of the tangent, and I'll use the points of point P to get the equation of the circle. Guys, it's very, very important when they ask you to give your equation of your straight line in y form, you must write it as y is equal to mx plus c. So you'll have your x value on the right-hand side with the gradient times your gradient, and then you're going to have your y-intercept on the right-hand side, the value of c. So it's only y by itself that's isolated on the left-hand side. So when we say write it in y form, you need to write it as y is equal to mx plus c, the equation of the straight line. Let's quickly have a look at doing this. So the gradient of OP, remember the formula is y2 minus y1 over x2 minus x1. And what I would like to encourage you guys to do is to label your coordinates so that you do not mix them up, because the order is very important. If you use y1 in place of y2 and then you leave the bottom as x2, x1, you are going to get incorrect answers. So label them. So let's say the center is the point, and it doesn't matter which one you use. You will still get correct answers as long as you do the order correctly. So you move from O to P or from P to O. It's important to do the order in the right way. So I'll call the point O x1, y1 and the point P x2, y2. Okay, so therefore I'm going to say y2 minus y1. So I'm going to get minus 6 and use brackets so that we don't make mistakes with the signs, all over x2. So you see I'm starting at point P again. I'm not starting at x1. I'm going back to x2, which is 2 minus 4. So this gives me minus 6 plus 5, which is minus 1, over 2 minus 4, which is negative 2. So therefore, my gradient of OP is a half. So the gradient of the tangent would be the negative reciprocal. So we reciprocate, or we take the reciprocal, of a half, which will be 2 over 1. We turn it around. Numerator becomes denominator, denominator becomes numerator, and we change the sign. So it's the negative reciprocal, negative 2. So the gradient of the tangent is negative 2. Now what you can do to find the equation of the straight line, you can use this form, y minus y1 is equal to m times x minus x1. Okay, so y minus y1, we're going to use the coordinates of the point P to find the equation of the straight line. Why are we using the coordinates of point P? Because remember, the straight line is only passing through the point P. It is not passing through the center of the circle. So you cannot use 4 and negative 5 as your coordinates on the straight line. You have to use 2 and negative 6. So we've got x is 2, y is negative 6. So it's y minus minus 6 is equal to the gradient, which we discovered was negative 2 times x minus x1, which is 2. So we get y plus 6 is equal to negative 2x plus 4. Take the 6 over to the right-hand side, and I get minus 2x plus 4 minus 6 is negative 2. So this is the equation of that tangent in y form. Y is equal to negative 2x minus 2. If the question doesn't specify, generally you will still write your equation of the straight line in this y form. Just get into the habit of doing that so that you always know then when they say y form exactly what the examiners mean. All right, guys, that's all we have time for, but I think we've covered quite a bit in this session. We've looked at circle of center. We've looked how important it is to understand the relationship between the tangent and the radius at the point of contact. Thank you so much for joining us. Until next time, cheers.